All right, class, let's do another nodal analysis problem just for practice. So here's one I found in some materials from the book. All right, so we're asked to do a nodal analysis on this and what solve for V sub x, where V sub x is the voltage across that center 10 ohm resistor. All right, so our first plan was the first thing in our plan was to redraw this a little bit larger. I've already done that, so you don't have to watch me do it. Ta-da, there we go. I've drawn it out just a little bit bigger. Now I need to pick a reference node. I'm going to make the bottom reference node equal to ground, attached to ground. So that means this whole, everything across the bottom here is at 0 volts. 0 volts. What other nodes do we have? Well, we have one node right there, so we're going to call that node 1. We've got another node here. Let's call that node 2. And we have another node right over here, and let's call that node 3. And whoops, I fall off of my video. Yes, there we go. All right. So notice that we have a voltage supply in this circuit, which is something we have not seen before. So we'll have to figure out what to do with that. But it's not a problem because if we look at this, well. Anyway, let's get my voltages in there. So we're going to want to solve for voltage 1, voltage 2, and voltage 3. If I look at this part of the circuit, I can notice that with this 80 volt supply, if that's 0, voltage 3 is 80 volts above that. So by examination, I can see that voltage 3 is equal to 80. So that'll simplify some of our analysis. We just need to find voltage 1, voltage 2 now. All right, let's put our currents in here. I'm not sure which way the current's going to go, but let's assume it's this way. So let's call the current in that direction I1. We know we have 2 amps coming up here. So there we go, I've got 2 amps. And then I'm going to have some current in this leg. Will it be in or out? Well, this polarity suggests, since it's a passive device, the current must be flowing from left to right. So let's call that I2, which would make this current 2. All right, and then over here, we're going to have some current caused by the supply. I'm not sure which way it'll be. Let's guess it's in this direction. So there will be I3, and then we'll have this current. There's our other unknown I4. So there we go. I've applied voltages and currents to every node. Let's go ahead. Oh, let's see, I can't zoom out any further. All right. Let's go ahead and write the Kirchhoff's current laws for these nodes. All right, so for node 1, the sum of the current in equals the sum of the current out. Okay, so for node 1, what current do we have flowing here? What's flowing in? 2 amps. We have 2 amps flowing in. What do we have flowing out? We have I1 and I2. There we go. There's our nodal, the current, Kirchhoff's current law for node 1. All right, let's go to node 2. Okay, so for node 2, what do we have? Current in equals current out. What do we have coming in? We have current 2 flowing in, and we have current 3 flowing in. There's my current in to node 2. What's my current out of node 2? It's I4. There we go. There's my Kirchhoff's current law for node 2. Current in, I2, I3, current out, I4. All right, so there we go. We've got the Kirchhoff's current laws for each one of these guys. I'm going to make a little space. Now, we want to use Ohm's law to write a formula for current 1, current 2, current 3, and current 4. So if I look at my circuit here, current 1, well, current is voltage over resistance. Current 1 goes through this 10 ohm resistor. What is the voltage across there? Voltage at the top minus the voltage at the bottom. So I1, voltage at the top, V1. If I V1 here, I V1 here, all right? Minus the voltage at the bottom, 0 over its value, 10. So there's my formula for I1. I2, well, that one's 2 amps. I2 is this voltage on the left minus the voltage on the right, divided by the resistance. What do we have? V1 minus V2 over 10. There we go. I3. If the current is flowing from right to left, it must be this voltage minus that voltage over the resistance. This voltage is 80, that voltage is V2, so it's going to be 80 minus V2 over 10. All right, current 4. The current's flowing from top to bottom, so it must be this voltage minus that voltage, V2 minus 0 over 10. All right, there's my 4 currents using Ohm's law and my original circuit. I'll let you guys look at that and think happy thoughts for a minute. All right, what I'm going to do next is take these Ohm's laws relationships and plug them in right here. So now this equation becomes 2 is equal to, now I1 is V1 minus 0 over 10 plus I2. I2 is V1 minus V2 over 10. All right, so there's my equation from node 1. I'm going to call that equation 1. It's not in final form, but we'll just take some algebra to do that. I'll assume you guys can do that. For node 2, I2, V1 minus V2 over 10. Plus I3, 80 minus V2 over 10. Put that right there where I3 is. Equal I4. What's I4? V2 over 10 goes right here. There we go. And there is our second equation. And we're going to call that equation 2. All right, we have 2 equations in 2 unknowns. Equation 1 from node 1, equation 2 from node 2. So now all we need to do is, okay, so we're done with the circuit analysis now. All right, all we need to do is put these 2 equations in standard form and solve them. I could do all that for you and you'd be very bored. So let me just show you what happens if I do some algebra to equations 1 and equation 2. I can put them in standard form like this, and there we have equation 1 and 2. Put them in matrix form, and they will look like this. And then I solve them with MATLAB, and they look like this. Yay! Are we done? We now know V1 and V2. Are we done? Well, I don't know. Are we? Let's go look at this. What were we asked for? we were asked for Vx. And Vx is V1 minus V2. So to get Vx, we have to take V1 minus V2. I'm not quite done.